to all of you. As usual, I experiment on. Um, you know that this is there is a magnet here, and that magnet, look here, I attract so that it can hang. So attract. This one attract having property of simply a magnet covered by a copper wire, insulating wire, and this is non-magnetic substance. There is no effect what here. Whatever I release it, it will fall down. Just look here. I goes to the opposite side. Here I lose it. Here it will fall down. Let us look. This bakelite substance. No effect. You know the bakelite substance. There is this magnet have no effect. Look here. I go to the close to this. No effect. Once again, I'm saying to you, no effect comes up. It is fall down due to gravity. It is fall down due to gravity. But it's a substance. Magnetic, no, not so electromagnetic. It's a magnetic substance. Magnetic substance. And while the rate of change of magnetic flux, current, and that current also produces magnetic field. So there is attraction. And from this portion you go, middle portion, it will let us go there. This portion when we fold it will fall, but it is not it will fall, but not fall in a directly just like a smooth one. It will fall your heavier one. The fall it is fall. Definitely it will fall, but that falling is very difficult. Let us look here. It's falling. It is falling, but not falling in a difficult. Why happened? What happened? This is falling one. This is the zigzag. It is falling. That is the substance of electromagnet. It is falling one, not the attracted one. I place it because the induction, but it will not so. I hold it in a very tight, that's it, and then I try to so fall in a rapid. Let us look here. It is not so rapidly, it will fall. But it is not fall so rapidly. Let us look here. It is fall. It will fall, definitely it will fall, but look here. So once again, I'm saying to you, this is fall, but not so rapidly. I will close it here, and then it will fall. It will fall, but not so rapidly. Let us look once again. It will fall, but not so rapidly. Let us look here once again. I'm saying to you, this is fall, smooth one. It will fall, but not so rapidly. It will fall. It will definitely fall, but not so rapidly. What happened? The beautiful experiment, but I keep it here, the same contact place. You know, there's a magnet place. It will immediately fall. No effect. Actually, experiment carriage. You wound a copper wire, wound inside a tube, copper wire wound, and a magnet is put here, put there. Then if non-magnetic substance put there and heavier in object fall down with a but magnet is fall, that induced rate of change of magnetic flux produce EMF induced. When a magnet is fall, it will fall, but it will take time. Why? According to Lenge's law. Lenge's law is a circular of change of magnetic flux induced with that coil. So Lenge's law states that the cause for which the current produced there of electromagnetic inductions, the rate of change of magnetic EMF induced with the coil, but it is always opposite the cause. What is the cause? The magnet is falling. North south, a magnet have a two pole, north magnet. Pole want to fall in front of which the due to circulation of current the front side north pole. So north pole repel each other. That's why it is facing obstacles to follow. Here the two show you, but I keep it here and then you look here, I keep it here in the tight manner. It not so fall rapidly. Let us look here. I fall to some extent I will here. Suppose not to some extent here. But it will not fall, no so rapidly. Let us look here and keep it here. I make it, I like to display you here, bending or something like that. And now I put it here. The smooth one, not so rapidly. Let us look here, not so rapidly. Once again, I'm trying to show you here so that, and then it can be a, let us look. See, it will not so rapidly, it will fall. Not so rapidly. It will fall because heavier in weight, but not so rapidly. It not so rapidly fall. Let us look here, I'm inverting here, and not so rapidly. There is no magnet. You look here, no magnet. But not, let us look here. The heavier one, heavier are near about 60, 70 grams weight, but not fall rapidly. Let us look here, I took a hold it here. I hold it here and slightly away and inverting, it is not fall. Incline and incline. Not so rapidly. Rapid. This is the induced EMF. That happened due to the fact I make it a clip type, and I'm inserting here. It is not so. It will fall, but not so. Not so that you know the heavier one. I then I like to say it slightly inclined way. I'm falling, trying to fall in inclined way so that you can understand it. The falling is that we inclined way in a inclined way. I have to fall it in a not so rapidly. It will happen to, but this is not happened to here. I put it here, it will immediately fall. Immediately the same place I say I introduce here the same place. But when this place is not so there is a small move place is there, the problem. So you hit this place. You look here, immediately it will fall. Once again I go to the we have a smooth place like this one. I introduce here, it will be immediately fall. I'm inserting here and I keep it here, this one. It will immediately it will be immediately fall, not so second time. Look here, it is immediately, not so second time. But the other hand, once again I'm showing to you, this not so rapidly. But here I place it here and this substance, then it will push here. It will not so rapidly fall. Let us look here, it is not so rapidly falling, but falling speed is not so rapid. Second experiment, once again the repeated experiment I like to show you. Put it here so that you can understand it. The circular shape, moment of inertia, all sorts of things is important here. What I would like to display you is last day that if we, I'm applying, problem arises here. 1 minute is inserting is like a problem here. Okay. We generally the linear force, it will be not, it will immediately fall down because of the weight. I generally will fall in rapidly fall, but it will rotational speed. You know though, this is the one that we like to display. Rotational speed you observe, that is fall down, taking much more time. So that is the, because circular shape have an importance to calculate the moment of inertia and how balances the work done dissipation of energy. So two things I display. One, the last one is the repeated, the much more time it is flying when it is rotated. Rotational force I am applying, torque is the moment of the force is called torque. A equal to ma you apply. The two forces are different over here. The same object. The rotational force will rotate, then immediately to some extent better time fly in the space in the room. But when we linear force apply, immediately fall down. So that is cases are fall down, but the cases being initiated from magnetic inductions equal to minus d phi dt. Phi is the normal magnetic flux. Rate of change of magnetic flux. Magnetic flux is the magnetic lines of force crossing unit area normally. That is the magnetic flux. And when the change took place, when it is falling, the change took place in the magnetic flux, magnetic induced in the coil, that magnetic lines of force passing through the rod. This rod to which the magnetic when the magnet is falling, the rod when the magnet is falling, the rod when this is the rod, the magnet is falling. Here, that is the magnet is far away from here. Look here how much it is far away. You can understand it, how much it is far away. So when it is falling, then it here. Now, when it is falling, it is take time to fall. It is falling because what happened? Not the magnetic attraction. I'm not to show you, but I show you at a later more. So far away, it taking you know you can far away from magnet here, and I like to release it here in one hand. So in that case, it will fall. Definitely it will fall, but it will take some time. Definitely it will fall, but it will fall much more time. That case taken magnetic substance. It is not possible. Subhik Kumar Bandyopadhyay, Bardhaman, West Bengal, India. Thank you very much. Morning.